Now we're going to define our first Kubernetes deployment manifest file. Now what this is going to do is it's going to tell Kubernetes to run a specific container in a specific way on pods. All of this stuff is things that you'll have to get used to, the terms you'll have to get used to when you start using Kubernetes. But a deployment is a really easy way to just get your containers running and working. Now, the actual deployment we'll use, the actual deployment manifest we'll use, is directly correlated to the deployment manifest that Kubernetes has in their documentation. The biggest difference is I'm using my own container image that is still Nginx, but it has custom HTML, which has a GitHub repo too, so you could always copy and paste that as well and build your own container. Now, if you're not familiar with containers or Docker Compose or Docker, any of those things, I do recommend that you check out my Docker and Docker Compose course. It will help you get a fundamental understanding of how containers work. Now, you don't have to know how containers work to use Kubernetes, which is pretty interesting. It's a good idea to know, but you don't have to. So what we want to do here is we want to grab this manifest file and actually just put it into Kubernetes. Let Kubernetes know about it, or our cluster know about it. So I'm going to go ahead and copy this file from the blog post. You could always stop and copy, or manually copy it if you'd like, or you could just go to the blog post and copy it there, or even the GitHub repo for this course. A lot of ways to do it, but in this case, I'll go ahead and do deployment.yaml, and I'm going to paste this in. Now, this is giving me a little warning about resource limits and stuff like that. That's because deployments themselves can have a lot of configuration. I'm just stripping it down to the bare minimum to really just get this thing up and running. So when we are talking about a deployment, again, think about this in terms of running a container application in Kubernetes. You're just telling Kubernetes, run this container application. And it's going to actually run 3 times across what's called pods. So these 3 pods are going to run your container. In this case, it's this container right here. It's going to run on those 3 pods and the latest version of it. You could get more specific with different kinds of tags. You can do all sorts of things for your container image itself. But it's going to run 3 times. Now, those 3 container instances that are running on those pods are going to be spread across our nodes. So on linode, it's going to be spread across whatever our virtual machine nodes are, specifically for this Kubernetes cluster, right? So it might all run on the same node. They most likely won't all run on the same node, but it definitely could. Now, if we wanted to get even more advanced, I suppose, or more explicit to how these containers run, there is a kind called pod that you can start defining things a bit differently than a deployment. Personally, I like deployments because it takes away a lot of the configuration you might need to do more manually, right? So this is just a little bit more automated. And that's pretty much it, right? So we've got our container image here. We gave it a name. We gave the deployment name, which I actually repeated 3 times for all of these different labels and specifications. And then I also declare a port itself. This port is corresponding to how Docker handles ports, or more specifically, the internal port. I'll get back to this when we go into the actual service side of this deployment. So all of this is going to do is actually just run these containers. That's it. So let's go ahead and start that. I'm going to get into the root of my project and do kubectl git nodes just to make sure that's working. I'll also do git deployments, and I'll see that I have no deployments just yet. So I want to actually create a deployment. It's simple. It's kubectl apply -f, apply a file, and that's k8 deployment.yaml. In other words, it's the relative path to that deployment file. You can also use a actual web page here as well. If it's a public URL, you can absolutely use that as well, and you'll see that from time to time. But anyways, so what this is going to do is actually create this deployment, which means that Kubernetes is going to pull this container image and start running it. So if I go up again and do kubectl git deployments, I should see that deployment there. Notice it says 3 out of 3 are ready, 3 is up to date, 3 are available. If I do kubectl git pods, I can actually see the 3 instances of it running, right? So like I said, you can define pods individually, or you can just use a deployment to do it for you. Defining them individually is a lot more tedious in my opinion, but now we have these actual deployments going. So if I actually want to go into one of these containers, if I want to like SSH into one of these containers or go into the shell, it's also pretty simple. It's kubectl execute, or exec-it. We want it to be interactive, an interactive terminal. And then we'll do deployments /. So the deployment / is just declaring that we are going to be executing this, whatever this command ends up being, into a deployment, which we grab the metadata name for it. And then we do --bin/bash. This is how we can get into the bash shell of that deployment, or, well, one of these pods. In this case, it is the very first pod right here. And we can actually see that we are in that pod. So we are like an SSH session into this pod, but it's all happening through kubectl and, of course, our kubeconfig file. So that's our deployment. There's a lot of things we could do with deployments. There's a lot of commands we could do. There's, well, just almost anything that you could think of you can do with Kubernetes once you have it deployed. So if you've never actually deployed anything on Kubernetes, congratulations, you have now done it. But the thing is, how do we actually see this? Well, if we go to kubectl and get services, we see that there is a service in here, and we also see that one has external IP. Now, we actually want an external IP service for this deployment. That just takes one more configuration. Now, there is also something called kubectl get and ingress, but that's not something that we have set up yet and will not set up on this particular tutorial. We will set up a service that will load balance our traffic to this deployment itself, and more specifically to those 3 pods. So that's something we need to do now. But at this point, as it stands, we have a deployed instance. We just can't reach it. A deployed Docker container instance, we just can't reach it. Now we want our deployment accessible to the internet, to the outside world, so you can actually, interact with the container itself. Now to do this, we're going to create another manifest for service, and it'll be in service.yaml. The first thing is the API version is just simply v1, and the kind is service. And then we want a few other things from our deployment. So I'll go ahead and just grab from metadata down to selector and match labels. So what I want to do is get rid of match labels and just use app, get rid of upperclass, and then rename this to being service. Okay, so this is the core service itself, and then I need to declare the type of load balancer. So declaring it as a load balancer, it will give us a IP address. So this is going to be an external IP address that we'll be able to use. And that's with conjunction of linode. Linode will also provide this within Kubernetes and the managed Kubernetes cluster. The next thing is we're going to go ahead and declare our ports. And that is going to be a protocol of TCP, which is a standard port for internet traffic, or a standard protocol rather. And then the port itself is going to be port 80, which, if you aren't aware, that is for insecure traffic or HTTP traffic. And then if we wanted HTTPS traffic, we would use the port of 443. Before I would ever set port 443, I would also want a security certificate and a whole heap of other things. But I actually wouldn't use a service for that. I would use an ingress controller. So it's a little bit different than this service, but that's actually how you would use HTTP. Then finally, with that port in mind, I want it to be mapped to my deployment, and more specifically, my deployment's container. So inside of my deployment here, if I scroll down, I've got this container port of 80. So that's what I want my target port to be, is 80. So I've got an external port of 80 mapped to an internal port of 80. This is actually very similar to like in the Docker container call here. If I actually grab this command and just pasted it in here as a comment, it's actually identical to doing something like this. Port 80 to 80. And then the Nginx port, the internal port for the container itself, is looking for port 80. The external port for standard HTTP traffic is going to be port 80. Like I said, if it was secure, it'd be 443 and also still mapped to port 80. You don't have to do an internal port of 443 necessarily. So there's definitely some more to it than just that, but that's just the general idea. But the thing is, this target port is hard-coded in here. What if my container doesn't use port 80, but rather uses 1234 or some other port? Well, that's why we actually named it here, is so that I can actually reference this name instead of the actual port. And then this way, it's still mapped from 80 to 80, but it's actually going based off of the name, and it's just a little bit more flexible for me if my deployment port ends up changing. So with this in mind, I'm going to go ahead and copy the relative path here and do kubectl and apply -f of that service. That service is now created. So kubectl get service, and then I can grab this service name right here. And this will give me details specifically for this one service. And if I hit enter, I'll see those things right there. And that's the service, right? Which is pretty nice. I could do it a little bit further and use another flag called out, and it's going to be JSON path equals to .status, and then we will use .load balancer .ingress, and we'll take a look at what that does. And that time it actually gave me no values, so I actually did load balancer incorrectly. It should be like that. And then this gives me this value. And if I do the 0th element .ip, I can get the IP address there. So that's actually how you get the IP address of that particular service. That's right there. Now, this JSON path is just a cool way to like break down the output itself. So if I do the load balancer, this is JSON data, so I can still use that dot notation in there, which is pretty nice. But as we see here, there's actually a proper IP address, which is this right here. So if I go to open and http:// of that IP address, I should see this page. This is my full deployment working on Kubernetes. And this is that custom, CFE Nginx page of just saying hello world, just to make sure that it's working. And it's a little bit different than the standard Nginx page itself. And so that's it. That's all we really need to do to deploy a container. Now, there is additional configuration that we would need to do to have private containers. This is a public container. Private containers require us to set up secrets and a few other things inside of Kubernetes to make sure that I can actually access the container itself, right? And I can also use other container registries, as in other places where containers are stored. But again, we need to add additional configuration for that. What we have here is just sort of like a hello world of it all, and hopefully gets you excited to learn a lot more about Kubernetes or Terraform, both things. I think they're both pretty fascinating and fantastic of tools. Thanks so much for watching this one. Hopefully you got a lot out of it, but what I want to do before we wrap everything up is to destroy everything and bring it back up. But before I do that, what I want to do is just show you that kubectl, we can actually apply an entire folder, right? Which is really nice. So if I have a bunch of files in here, that's the way you do it. It's very similar to Terraform, where we can, basically treat it as one big file. Kubernetes isn't any different. We can treat all of our YAML files as one big one, just as long as we use this separator here between those files, which is also pretty cool. And we can also take down things with kubectl and delete -f k8s, and that will take everything down and to bring it right back up. And there we go. Now, the thing about this is that then we want to know a couple details about our, actual, service and deployment. So for example, if I wanted to just say, K8s apply, then I would do this right here. And that's something I do all the time. I don't actually specify the single file unless there's a very good reason to do it. I instead assume that that whole thing is ready to be applied unless for some other reason. That is one thing. And then K8s delete. I would actually probably change apply to be just, this would be TF apply most likely. That's how I would end up doing it. And then apply just being Kubernetes apply. Although I write this so often that I don't always use the makefile specifically for this. And of course, if you're on Windows, you're not going to either. So that's one thing. But then I also want to have a command for getting the IP address for any particular service. So I'll go ahead and say my CFE Nginx IP, and that's going to be just this command right here, which is what we saw before. And the reason I have this is just a shortcut so I can see what that IP address is. Now, if you have a domain name, you can absolutely map this domain name to this IP address. That will generally be okay to do, unless, of course, you take down the service, in which case it's not necessarily going to be the same IP address, which is the case for me in this case, right? And so there are definitely more robust ways to handle changing services and IP addresses inside of Kubernetes, but it's just outside the context of what we're trying to do here. So those are the things that I would usually end up doing, is all of this. And so the other thing is TF maybe destroy, and actually just going off of that being apply and then dash destroy. And so like we said before, you can absolutely do this with make and then TF destroy, or just simply calling this command right here, and that will destroy everything, especially if we say yes. Then our Kubernetes cluster will not work. And at this point too, this hello world should already be down because I took it down anyway. So that will definitely be down. But the thing is, if you make your applications stateless, that is, it's not required to use a database, for example, then you can take these things down and bring them right back up just as easily, right? So I just took it down, and if I wanted to take it back up, it would be, first off, I'd have to Terraform everything. So this, of course, is going to allow my Kubernetes cluster to even be created. And then after that's finished, then I would run K8's apply, which is actually pretty easy to do. And I want you to get sort of comfortable with doing this because you might use this over and over in other projects. And that's really the point, is to be able to just do this really, really quickly and get comfortable with destroying things, bringing things back up, because Kubernetes does that all of the time, right? So if you start thinking in terms of like, oh, my deployment itself is going to be destroyed frequently, then inside of your container, you would not want to store things in there. There is a way to persist data, and it's just not this way, right? So you'd use external volumes or even managed database services and stuff like that to really have your data stored, where you think of your containers and in fact your entire infrastructure as being flexible enough to just be able to take down. I mean, that's a pretty neat thing about a lot of these modern tools. And so I'm going to let this actually finish. It should take only a few minutes, hopefully, if it's sticking with the current trajectory. Okay, so it took a couple minutes. It's done. Kubectl, apply -f, K8s, enter. And there we go. And then, of course, we get our IP address and make CFE Nginx IP address. And it looks like maybe it's not quite ready yet. So let's go ahead and try it again. Kubectl get service, and it does take a moment for that to finish. So because it's going to provision the IP address, notice that it's pending here. So we could always wait for that to finish. Okay, like another minute or so, and it was done. Here is that IP address. We can open it now into our browser with typing out open http:// and it's going to load. It's probably going to be up, and this is like a few minutes, right? It's pretty amazing how quickly I got an IP address. It's pretty amazing how quickly I probably have all the deployment working. So let's just check, and there we go, and everything's ready. So it might just take a moment for the IP address to be fully propagated and working and accessible, and there it is. So literally under 5 minutes, I created a Kubernetes cluster. I actually deployed a Docker container onto it, and there we go. And then in another few seconds, I can just delete it with simply, this command of TF destroy, and then just saying yes. It's fantastic. Really, really cool. The only aspect that is another kind of complicated and tedious thing to do is the role-based access control from here. It's not really that straightforward. in terms of getting all of the assets working in a super automated fashion. But it is something that I'm really interested in learning more about. So at some point, I hope to find that. But anyways, thanks so much for watching. Hopefully you got a lot out of this. I do recommend that you destroy all of your infrastructure if you haven't already, because, well, you will get charged for it if you don't have it destroyed. Luckily, it's not that expensive. It's like $30 a month, and it's well worth learning more about Kubernetes at that rate, I think. So thanks again for watching. If you do have any questions, please let me know in the comments. If you want to see anything else related to Terraform or anything else related to Kubernetes or both, let me know as well. I do plan to cover these things a lot more in the near future, so be sure to check those out when they come out. Thanks again.